set up a high voltage system, suddenly more energy is coming out. Nikola Tesla called it the infinite energy field. How this is operating.
A forgotten wooden crate was unsealed in a quiet New York University basement. Inside lay a strange copper device marked Wardenclyffe. The name sent chills through the room. It was Nikola Tesla's long-lost resonator, untouched since 1943.
That was mastered decades ago.
They thought it was just another relic from the past. But when researchers powered it up for testing, something impossible happened. It was so shocking that the entire lab had to be immediately evacuated. The forgotten crate in the basement. It all began in March 2025, far beneath the bustling streets of New York City, inside the engineering building of New York University. A maintenance crew had been clearing out the lower storage rooms that hadn't been touched since World War II. The space smelled of old oil, varnish, and time itself. Boxes filled with obsolete lab equipment sat stacked like forgotten tombs. Behind a wall of rusted filing cabinets, one worker's flashlight caught something unusual. It was a large wooden crate sealed with black pitch and stamped with symbols from another century. Bolted to the crate's front was a brass plate, dull with age but still readable under the light. It said, "Wardenclyffe Experimental Tesla Laboratories, 1923. That name alone sent ripples through the team. Wardenclyffe was not just any project. It was the name of Nikola Tesla's dream, a massive experimental facility built on Long Island in the early 1900s, where he planned to transmit electricity wirelessly across the Earth. Tesla believed that the planet itself could act as a conductor, allowing energy to travel through the ground and air without wires. The idea had failed in its time, partly because it frightened investors, and the Wardenclyffe Tower was demolished in 1917. But this crate, apparently shipped from that very site decades later, suggested that something from those experiments had survived. When they brushed off the dust and pried open the steel latches, the wooden lid came free with a groan. Inside, under layers of straw and cloth, rested a strange and beautiful machine. It was a metal cylinder about the height of a man, wound tightly with reddish copper coils that still gleamed faintly in the dim light. Glass insulators ran along its frame, and a network of delicate silver wires joined them in looping circuits. It looked both primitive and ahead of its time, like something from an age that had skipped a few steps in science. Tucked beside the device were yellowed papers in a leather envelope, each page covered in fine, slanted handwriting. The ink had faded to blue-gray, but the signature at the bottom of several pages was unmistakable: Nikola Tesla. There were also small notes scribbled in the margins, some written in Serbian, others in English, filled with calculations, wave diagrams, and the phrase repeated again and again: Earth frequency alignment. The crate's transfer tag gave only one clue: moved from Long Island facility, 1943. That meant it had been relocated during the Second World War, likely for safekeeping when the U.S. government began seizing private research materials with potential military value. Records later showed that several of Tesla's unfinished projects, along with equipment confiscated after his death in 1943, had been temporarily assigned to university laboratories under Army oversight for cataloging. NYU's engineering department, already collaborating on radar research at the time, was one of the designated storage recipients. Somewhere between the war's end and the post-war renovations, the crate was simply misfiled, sealed behind newer infrastructure, and forgotten for 80 years. When the find was reported, the university's electrical engineering department immediately took interest. The initial guess was that it was a high-frequency resonator similar to those Tesla had used in his wireless power and energy transmission experiments. These devices could generate extremely high voltages using oscillating electric fields. They were the forerunners of modern radio, radar, and even today's wireless charging systems. The university granted permission to study and document it, seeing it as both a historical artifact and a scientific curiosity. The team labeled it Resonator 1W in honor of Wardenclyffe. In the following days, technicians carefully examined the device. They noticed the craftsmanship, the hand-tightened brass bolts, the polished wooden supports, and the coils wound with perfect symmetry. It was not a factory-built object, but a masterwork assembled by hand. The more they studied it, the more it seemed less like a prototype and more like a completed instrument. Then came the moment that unsettled them. While checking for corrosion, a technician tested the outer copper coil with an electrostatic probe. The needle twitched. Thinking it was interference from nearby lighting, they repeated the test. The result was identical, a measurable charge. The copper was holding a faint, self-sustaining potential despite being completely disconnected from any power source. They moved it into an isolated lab, then into a Faraday cage to eliminate external fields. But the reading persisted. The device seemed to emit a soft, rhythmic vibration, almost below the threshold of hearing, like a tuning fork that had never stopped ringing. To most of the researchers, it was simply an astonishing anomaly, an old coil that somehow retained residual charge after decades. But to the senior professors, men and women who had studied Tesla's unpublished papers, the discovery carried a more unsettling implication. They recalled Tesla's writings about resonant circuits that could awaken the electrical heartbeat of the Earth. And suddenly the words Earth frequency alignment took on a different meaning. As they prepared to connect modern diagnostic instruments for the first test, the atmosphere in the lab shifted from curiosity to unease. Everyone wanted to see what would happen when 21st century precision met early 20th century genius. No one realized that the moment they powered those instruments, they would close a circuit that had not been active since Tesla himself last stood before it. The test that went wrong. On the morning of March 17, 2025, the atmosphere inside New York University's engineering basement was calm but charged with excitement. The plan was simple: send a low-power signal through the circuit and record its response. It was the same procedure done with countless old devices. Nothing about it should have been dangerous. The graduate engineers were assigned to lead the test under the supervision of the department's head of experimental physics. They used a modern AI-controlled spectrum analyzer, which was a machine capable of sending a tiny, precise electrical pulse into a circuit while measuring its response across millions of frequencies. The analyzer would start at one frequency, then automatically adjust to find the resonant points where the circuit naturally vibrated. The graduate engineers connected the analyzer's test leads to two contact points on the resonator, double-checking the grounding cables as per safety rules. The power input was set to 10 milliwatts, which was barely enough to light a small LED. The goal was to map, not activate, the device. At 10:47 a.m., the supervisor gave the go-ahead and the graduate engineers pressed run. The analyzer sent its tiny pulse into the coil. For a few seconds, nothing happened. The monitor displayed a smooth curve and the machine hummed softly. Then, without warning, the screen froze. A jagged spike shot across the output graph. Before anyone could react, a sound like tearing metal filled the air. A flash erupted from the Tesla device, not a spark, but a blinding arc of white blue light that shot 12 feet across the room and struck a metal shelf. The explosion of light and sound was deafening. The air crackled as if electrified. Tools rattled off benches and a fluorescent lamp shattered overhead. One researcher screamed as her hair stood on end, charged by static. Monitors flickered and went black. The smell of ozone and burning insulation filled the room. The supervisor shouted, "Kill the power!" And the graduate engineers slammed the emergency stop, cutting all current to the system. But the coil didn't stop. It was glowing alive and pulsing with light from within, like something breathing electricity. The voltage meters had gone dead, but portable field detectors in the room kept clicking wildly. Radiation alarms started to sound. Fire detectors joined in. Then came the blaring voice over the intercom. "Evacuate immediately. Level B, Level C, and Level D. Clear the area." Within minutes, the basement and two upper floors were emptied. Students and staff poured into the courtyard, coughing from the sharp metallic air. Some said they could still feel the vibration in their teeth. Back inside, security cameras caught something eerie. Even with every breaker tripped and power cut off, the coil kept humming faintly but rhythmically, as if drawing energy from something unseen. Technicians watching from the control room saw faint ripples on nearby instruments. Magnetic sensors spiked. The hum lasted for almost 4 minutes before fading, leaving the air silent once more. When the all-clear was given hours later, no one dared re-enter the lab without full protective gear. The floor bore scorch marks, and the shelf where the arc had struck was half-melted. The incident log simply described it as an unexpected resonant surge. But everyone present knew what they saw was far beyond a normal malfunction. The impossible reaction. By the afternoon of March 18th, the lab no longer looked like a research facility. It resembled the aftermath of an accident scene. Yellow caution tape stretched across the hallway, and warning lights pulsed in the dim air. Technicians and forensic engineers from the university's safety division, along with specialists from the State Energy Commission, arrived to investigate. They carried radiation detectors, magnetic sensors, and chemical analyzers. Every movement inside the basement was cautious and methodical, because no one could explain how a machine from the 1920s had produced the kind of electrical discharge seen the day before. The first step was to document the physical condition of the lab. The walls were scorched, and the concrete floor bore a black circular stain where the Tesla coil had stood. Shelving units were warped from heat, and fragments of melted copper wiring clung to the edges of tables. The smell of ozone lingered in the air even after hours of ventilation. Investigators wore respirators because the chemical readings showed traces of nitrogen oxides, which are gases that form when electrical arcs superheat the air. Prolonged exposure can burn the lungs and throat, and several engineers who had remained in the basement during the initial incident had already been treated for coughing and eye irritation. As the safety team continued their inspection, they began to uncover the real reasons the evacuation had been ordered so quickly. When the resonator had discharged, it created an electrical arc that reached nearly 2 million volts. That was powerful enough to vaporize several copper contacts inside the testing cables and produce a sudden burst of metallic fumes. These vapors combined with the heat to form ozone and a class of toxic compounds known as polychlorinated biphenyls, or PCBs. PCBs were once used in electrical insulation fluids, but had been banned decades earlier after being linked to cancer and nerve damage. The investigators concluded that some of the old transformer oil in the basement wiring must have contained PCB residues. When the Tesla device overheated, it burned through that insulation and released the poisonous smoke. What the engineers described from inside the lab sounded like a storm of light and sound. The air had turned bluish-white as the electrical discharge filled the room. The intense energy ionized the atmosphere, which means it stripped electrons from the air molecules and made them conduct electricity. The noise that followed was not an explosion, but a continuous roar, the sound of electricity forcing itself through air thick with charged particles. When the emergency lights cut in, the team had seen glowing sparks moving across the floor, jumping between puddles of condensed moisture and metal conduits. Several computers had shut down on their own, while others glowed faintly even though their switches were turned off. The emergency ventilation system struggled to clear the thick metallic smoke, and within minutes the intercom ordered the full evacuation. When investigators replayed the footage from the security cameras, they saw that the decision to evacuate had been justified. The temperature near the resonator had reached levels high enough to melt parts of the steel supports. Chunks of flooring had been scorched so deeply that sensors embedded below the concrete were destroyed. Sparks from the conduits had ignited cable insulation, sending flashes across the walls that looked like crawling fireflies. Automated sprinklers and fire suppression foam eventually extinguished them, but the damage was extensive. The safety alarms that echoed through the entire building were not malfunctioning as initially believed. They were responding to a cascade of faults triggered across several systems at once. When the hazmat crews finally entered, they found a magnetic field still lingering around the Tesla coil, even though every power breaker in the building had been shut off. Portable magnetometers showed that the field strength near the device was powerful enough to interfere with sensitive electronics. Reports from a nearby hospital confirmed that several pacemaker monitoring systems had briefly malfunctioned during the surge, forcing staff to switch to backup units. For that reason alone, the basement remained sealed under strict isolation protocols for 2 days. Once the readings dropped to safe levels, a small team returned to examine the device itself. What they found deepened the mystery. The resonator was still warm to the touch even though it had been disconnected for nearly 48 hours. The brass bolts were hand-tightened, the wooden supports had been varnished to resist humidity, and the copper windings were perfectly wound. It looked like a machine built by an artist as much as by an engineer. When the technicians tested the outer surface using an electrostatic probe, the needle jumped slightly. The copper coil was holding a faint electric charge, even without any connection to a power source. At first, they assumed the reading came from background interference or static electricity in the air. However, after isolating the coil inside a Faraday cage, the reading persisted. A Faraday cage is an enclosure made of conductive metal that blocks external electric and magnetic fields. Inside it, no outside signal can reach a device. Yet the Tesla coil continued to register a weak but steady charge as if it were producing energy within itself. Data from the damaged analyzer provided one final clue. The output graph showed a narrow frequency spike moments before the system collapsed. The investigators realized that something inside the resonator had entered a runaway feedback loop. It was as if the machine had taken the tiny pulse sent by the analyzer and fed it back through its own coils over and over, amplifying it with each cycle. This kind of reaction, sometimes called a self-sustaining oscillation, occurs when energy inside a circuit reflects upon itself faster than it can dissipate. The process can increase voltage exponentially until components fail. In modern electronics, such feedback loops are prevented by dampers and regulators. But a device designed before that technology existed could easily spiral out of control. The theory fits the physical evidence. The heat, the chemical reactions, and the electromagnetic field all pointed to a runaway current loop that had consumed the system from within. However, one puzzle remained. When an oscillation like that burns itself out, it should stop completely once the energy is exhausted. Yet the resonator had stayed active long after all measurable current sources were cut off. Even the melted analyzer was incapable of storing charge, and there were no batteries, capacitors, or chemical cells inside the crate. The technicians could only describe it as an impossible reaction. No one could explain how the coil remained warm or why it retained a measurable electric field. Instruments around it continued to detect faint pulses that came and went with irregular timing, as if the machine were still trying to complete a cycle it had begun days earlier. That unresolved question marked the turning point of the investigation. It led researchers to re-examine the building itself and everything connected to it. A chain of hidden connections. When investigators began mapping the electrical layout of the laboratory, they discovered something that made them stop. The building itself seemed to have taken part in the reaction. Every piece of metal inside the structure, from the floor beams to the water pipes, had become slightly magnetized. The instruments showed that these metals had briefly carried current at the same moment the Tesla device overloaded. It appeared that the experiment had not been confined to the resonator alone. The entire laboratory had unknowingly become part of the same electrical system. The team traced the path of the wiring and grounding cables to understand how this was possible. Under the concrete floor ran a network of steel reinforcement bars known as rebar. In modern construction, rebar provides strength to the concrete, but it is also a continuous metal grid that conducts electricity. The investigators realized that the base of the resonator had been sitting directly on the section of the floor containing that grid. During the surge, the current likely passed through the rebar, using it as a pathway to spread the charge through the foundation of the building. From there, the current traveled through the grounding cables that connected the laboratory to the rest of the university's electrical system. Grounding cables are meant to carry excess energy safely into the earth during a fault, but in this case they did the opposite. They provided a ready-made highway for the surge to move outward. The power followed metal conduits that ran up through the walls and ceilings, then spread through the water pipes that linked the basement to the upper floors. The investigators found faint burn marks around several pipe joints, a clear sign that electricity had passed through them. When the physics department examined the data logs from nearby laboratories, they saw synchronized spikes at the exact moment of the incident. Magnetometers located more than 100 meters away had recorded identical fluctuations. Even rooms with no electrical connection to the experiment had shown temporary magnetic interference. In one office, a compass had turned several degrees on its own before settling back. The pattern suggested that the surge had traveled not only through the wiring, but also through the surrounding air as a strong electromagnetic pulse. The most puzzling finding came from the university's central server room. The main computer systems had shut down during the event, but post-incident testing revealed no burnt circuits and no physical damage. It was as if a powerful burst of energy had passed through the space, strong enough to interrupt the digital signals but too brief to leave a trace. The effect matched what would happen if a high-intensity magnetic pulse crossed the room. These results led to an unsettling conclusion. The Tesla resonator had not simply overloaded within its own components, it had used the entire structure around it as an extension of its circuit. The metal framework of the building, the water pipes, and even nearby equipment had all combined into a single massive electrical network. For a few seconds, the university's engineering wing had become a living circuit. When the team presented their findings, the administration made a swift decision. The resonator was to be sealed inside a lead-lined containment crate and handed over to federal authorities for further study. As workers prepared the shipment, one question continued to trouble the engineers who had been there from the start. If the building had become part of the circuit, then what exactly had been feeding it once the power was gone? Tesla's unfinished design. When the investigation team examined the handwritten notes that had been found inside the crate, they began to understand why the test had gone wrong. The pages were filled with complex equations, but several lines were crossed out and sections were left blank. Tesla had been refining a principle he called resonant terrestrial induction. The idea was to send electrical energy through the Earth itself by matching the planet's natural frequency. If the frequency could be tuned precisely, energy would no longer need wires because the planet would act as the conductor. The more they studied the drawings, the clearer it became that the device from the crate was not a finished invention. It was a working prototype that Tesla had been testing at the time of his financial collapse. Many of the handwritten comments showed frustration, as if he had been struggling to stabilize the oscillations. One note read, "Feedback uncontrollable, harmonic runaway." Another line, barely visible under a smudge of ink, said, "Delay construction until stabilizer perfected." Tesla never had the chance to perfect that stabilizer. When his Wardenclyffe project was dismantled, he lost both funding and laboratory access. The device that was later sealed in the crate had been built without the final regulating components. It was an unfinished design, capable of producing enormous resonance but without the control system needed to stop it once activated. That flaw, the investigators realized, explained everything that had happened in the university basement. During the March 2025 test, the AI spectrum analyzer had scanned through millions of frequencies in search of the circuit's resonant points. In simple terms, a resonant point is the exact frequency at which an electrical system naturally strengthens its own signal. When energy at that frequency enters the system, it does not fade away but keeps growing stronger. Tesla had tried to find this exact frequency manually by adjusting the power and timing of his early generators, turning knobs and measuring small changes in output until the response peaked. The AI analyzer did the same process automatically but with far greater precision. When it reached that precise value, it unknowingly triggered the unstable feedback loop Tesla warned about in his notes. A feedback loop happens when the energy coming out of a system is accidentally sent back into it again. Instead of the output leaving the circuit, it re-enters and combines with the next signal, making it stronger each time. The process keeps repeating until the buildup becomes too great for the components to handle. In this case, the Tesla resonator's copper coil began feeding its own signal back through the steel rebar, electrical conduits, and water pipes that surrounded the laboratory. Each cycle strengthened the returning current, turning the building itself into part of the circuit. The power increased far beyond what the device could safely release, which produced the intense heat, the blinding light, and the powerful magnetic surge that destroyed the analyzer and shook the entire laboratory. Tesla had warned in one of his letters that connecting a transmitter directly to the Earth without proper control could make the energy waves collide and grow unstable. The investigators also discovered that several missing parts in the device were supposed to track something called phase alignment. Phase alignment means keeping the timing of the voltage and current perfectly matched as they move back and forth through a circuit. If that timing slips even a little, the electrical waves begin to add to each other instead of balancing out, which makes the power rise sharply. Tesla's machine had no part to correct that problem. Once it reached its natural frequency, the energy kept building with every cycle until the materials could no longer withstand the stress. In a sense, the test had succeeded more completely than anyone intended. For a few moments, the resonator functioned exactly as Tesla had dreamed it would. It had coupled with the Earth's electromagnetic field and begun drawing energy directly from it. The only problem was that the mechanism to regulate that connection had never been built. What Tesla had left behind was a doorway that could open but not close. Weeks later, long after the device had been removed, the consequences of that unfinished design began to reappear in subtle and troubling ways. The reawakening. Weeks after Nikola Tesla's experimental coil was removed from the university basement, strange activity began to reappear in the sealed lower levels. At first, the maintenance crew noticed harmless oddities. Small LED lights on unplugged equipment flickered faintly. Metal tools gave off mild static shocks. Phone signals cut out whenever anyone walked near the old chamber. Most assumed it was leftover electrical charge or damaged wiring from the power surge that had forced the evacuation weeks earlier. But when the pattern kept repeating with perfect regularity, the team realized something was still happening underground. The university called in a group of electrical engineers to investigate. They disconnected every circuit breaker and confirmed that the power grid to that section was completely dead. Yet when they used precision voltage meters, they detected weak but rhythmic voltage spikes across several grounded metal surfaces. The readings were strange, low enough to be harmless but too consistent to be random. When the data was plotted on a graph, the voltage rose and fell in a repeating cycle, as though an unseen current was pulsing beneath the floor. The team began tracing the interference, and all the signals pointed back to one location, the spot where Tesla's device had once stood. Out of curiosity, they used additional instruments, a Geiger counter to check for radiation, and a magnetometer to measure electromagnetic activity. Both devices began to register faint repeating oscillations at exactly 700 kilohertz, the same frequency Tesla's coil had produced during the unexplained surge in March 2025. That finding changed everything. The basement had no power, no external feed, and yet something down there was producing electromagnetic pulses. The oscillations were steady and stable, suggesting that some kind of resonant field was active. In plain terms, the ground itself seemed to be vibrating with leftover energy, as if Tesla's machine had charged the surrounding space and the environment was still ringing from it, much like a struck bell that refuses to go silent. As word spread quietly through the research department, theories began to divide the staff. Some believed that Tesla's coil had tapped into a natural global resonance, possibly linked to the Earth's magnetic field, and that energy was still feeding back from the planet itself. Others argued the coil had only left behind a kind of electrical afterimage, a lingering echo of high-frequency energy trapped in the surrounding structure. But a few engineers, reviewing deeper data, suggested something more disturbing. They proposed that the coil had not generated the signal at all. It had triggered a response from an external power source. The energy, they warned, could be coming from deep within the Earth's crust or from the upper atmosphere, where Tesla had once theorized natural power lines of energy existed. That means Tesla's invention might have made direct contact with the Earth's internal energy network, a system that regulates magnetic balance, radiation flow, and atmospheric charge. Even a small disruption in this field could disturb the stability that protects life from solar radiation and cosmic interference. The growing strength of the signal suggests the process is still active, slowly increasing in intensity. In simple terms, the coil might have connected to something vast and self-sustaining, something that never turned off. If that link keeps strengthening, the effect may spread far beyond the sealed lab, interfering with communications, weather systems, and even the magnetic shield around the planet. What started as a forgotten experiment could now be rewriting the planet's pulse, awakening a current that was never meant to be touched. Humanity may have just switched something back on, something ancient, global, and uncontrollable. What do you think about the team's decision to power Nikola Tesla's device? Comment down below.